everybody, welcome. Thanks for coming. This is your first session, so I hope you're all awakened by now. We're going to talk today about adding advanced security to the mix. We're going to talk today about some trends that we're observing. We're going to talk today about why do we believe service mesh is important. My name is Bojer, and I'm here with my esteemed colleague, Vinay Venkataraghavan.
Good try. Some would say Vinay Venkataraghavan.
Some.
Good morning.
Apologize about that. And we're going to try to explain you what do we do here at Palo Alto Networks and why we think this is important. So before we start with this, if you can just give me a little bit with a raise of hands, how many of you is actually familiar with the Istio? Thank you. How many of you are actually familiar with something other than Istio in a service mesh? And the last one is that how many of you actually have to have security teams sanction your apps before they can be deployed in production? We're going to today talk about the containers and microservices trends. We're going to tell you about why some of it is complex and things that you have to worry about and that we observed. We're going to talk about one implementation of the service mesh, Istia, which is arguably probably the most predominant out there. We're going to talk about some importance and advantages of it, some pitfalls, and we're going to then explain to you guys how we solve some of these with our Palo Alto Networks Istio solution. And then at the end, we're going to have a demo time, show you how it all actually gels together. So back in the days, we were all familiar with the monolithic applications. You had usually three-tier model, mainly done with a presentation model and some kind of middleware, and then persistence model or the storage. There was very understandable relations between these three components. They were somewhat decoupled, but yet they were very static back in the days. So really, although we claim this is decoupling in a three-tier architecture, our relations were very known and understood. Well, what comes next? We came up with a service mesh. We came with microservices. We came with the containers. So now containers are just the current trend that helps you get to the applications. But they helped us actually kind of decouple even more our services, get more performance out of them, deal with the scalability, work for reliability, and actually make things a little bit easier. And so we thought. Because what we figured out, as you deploy your monolithic applications into the sort of microservices architecture, you really have to understand relations between these services. Some of them are very related to each other. Some of them are unrelated. Some of them have to scale really quickly. Some of them, you don't care much about. They're much more static. You need to understand how closely they live to each other so they can deal with the latency issues. You have to figure out what's that atomic service component you got to worry about, or how narrow do you need to go with each of your services. So there's a lot of questions you got to ask yourself before you deploy microservices. So now, deploying microservices itself is very easy. Everybody that did any development can probably figure out very quickly how to deploy the service, microservice, or how to develop one. What wasn't easy, figuring out all the other relations between them. Let's talk security. In a monolith architecture, security is more or less known. You're going to put your security principles mainly around perimeter, your choke points. What do you do in microservices? There is really no perimeter anymore. It's kind of dissolving. You're talking about north-south in a monolithic architecture. In microservices, you got to talk about north-south and east-west and up and down and left and right. So what do you do with it? How do you figure this out? What we figured out is that actually building those microservices is easy, but to build them right is actually really hard. So now, imagine a world in which actually microservices are secured. Imagine the world in which agility of your DevOps is not impeded by your security teams. where it doesn't take 2 weeks to approve your application, that you can develop every day, and do updates every day, and release every day. So this is the world we kind of live every day in Palo Alto Networks. Coming from the security side of things, and especially enterprise security doesn't move that quickly. It's actually super slow. It actually slows down DevOps teams. So how to combine these two things together is a question. And we're going to show how to do that. So now, as microservices were maturing more and more, there were some other frameworks and components which allowed us to actually easy out of some of the job. Starting with the Kubernetes, #1 orchestrator out there, it's very helpful in deploying and orchestrating your applications. It helps you with lifecycle management. It helps you with scaling out, scaling down. It does all the health checks for you. Developers don't have to worry about it. However, it's lacking a little bit on network security policies, because it does have some. However, those are usually at the layer 3, layer 4. So ports, basically 5 tuples, right? Well, service meshes came in. And service meshes came in to actually help with complexity of the networking and topology and routing. But also, they also came in to kind of figure out how to solve some of the security issues. Istio, arguably, probably the #1 implementation of the service meshes, decided to kind of figure out, we're going to help you with the routing, we're going to help you with the security. However, they just defined the framework around security. They let you implement it yourself to figure out how they want to deal with it. On the left screen, on the left side of the screen, this is just the visibility into the Twitter microservices architecture. You can Google it. It's all over the place. I mean, that does look easy. How do you apply security to that? Some of them would like to call this service mesh, not service mesh. So it's a really challenging problem. So we at Palo Alto Networks look at this and try to figure out how actually can we help, how we can bring enterprise-grade security into the service meshes. And there are a couple of ways we decided we're going to go along this. We figure out we need to bring our high-level grade security into service mesh. So you got to be unified. It should feel the same. It should definitely do the same thing that we do everywhere else. We figure out visibility is very important, because if you don't see what's going in your interpod, intrapod traffic, then how can you know what's really going on in your network? These are all blind spots. Some of the other services like service meshes, they can help you with some of that, but they only know what they know. So the set of the protocols they support is very limited. And the worst thing is that really don't knowing what you don't know, which means you don't have visibility over things that service meshes can't see. So we can help with that. And on top of that, obviously, there is security for ingress, egress, and intramesh itself. So with all of that said, I'm going to give the microphone to Vinay, so you can tell us how do we actually do this.
OK, great.
Or do we?
Hopefully. Great. Thanks a lot, everyone. And thanks, Ivan. When we asked you guys how many of you are adopting Istio, it was great to see most of you raised your hands. So it looks like I'm going to be not preaching, but speaking to the choir here. But let's take a pause and figure out, why are we doing this, right? So we talked about how microservices are dominating predominant production architectures today. But why are we doing that, right? And when I try to answer that question, I think it's driven by agility, right? Because enterprises need to deploy their applications. They need to allow the users to access those applications. And there needs to be a very tight feedback loop, right? Consequently, your developers need to move very, very fast, right? So let's talk about then, if we are proposing the industry as a whole, there are service mesh as an architecture, and Istio in particular, How does Istio help that perspective, right? Your developers now have the ability to reason about your applications as code. Everything is as code. Kubernetes and Istio allow you to reason about your infrastructure as code. Now you see how that agility is facilitated. However, and I'm going to caveat my next statement by saying I am a developer, but I straddle both worlds. Developers are not the most security conscious. I mean, they are working under a very, very tight timeline, so they need to develop and deploy code very, very fast. So it is up to the security teams to enforce best practices, make sure that their deployments are secure. So from the first perspective, so the developers now have the ability to deploy all their applications, and they can use Kubernetes and Istio primitives to actually connect their services, ensure discoverability, and ensure that their services are actually usable. Now, I've spoken to many, many security practitioners out there, and I also saw some of you raise their hands. These applications can never see the light of day until it's sanctioned by their security teams. And I've already had a chat with a few of you here who can validate that, right? So what does Istio do to provide that, right? So Istio actually allows you to abstract out fundamental services that your development team, that your applications absolutely need. So let's talk about what they are, right? Encryption. You need encryption between your services. You need mutual TLS. You need authentication, and a host of variety of services that are required by each and every application. So now you can see how this provides security, but also fosters agility by abstracting out these services, and your development teams can now focus on their job at hand, which is the line of business application, right? So Istio provides these primitives by giving you these capabilities and allowing you to enforce these capabilities with zero changes to your code. And I think that's a win-win situation. So now let's talk about, really briefly before we get into the really meat of this presentation, but how does Istio do this, right? So Istio is fundamentally comprised of three major services. One is Pilot, the other one is Mixer, and the last one, but not least, is Citadel. So we're going to focus on the Mixer architecture here today, but I want to quickly just round out the value proposition provided by Pilot. This is what allows you to connect your services, allow you to do the traffic management, load balancing, service discovery, et cetera, right? And Citadel allows you to distribute certificates to make sure that your applications are authenticated and also use the necessary encryption. So having said that, let's get into what the services provided by Mixer are and how we can leverage that to provide a deep security for all your applications running on Kubernetes with Istio. So this slide talks about the Mixer architecture. I wanted to quickly go over it and describe the salient aspects of this. To your right, to the right of the screen, fundamentally it's all hinges upon the Envoy proxy. So typical deployments in a pod, which is the fundamental unit of work in a Kubernetes environment, is the fact that there's always an Envoy proxy that fronts your application. So Envoy is the one that actually has a very rich set of attributes that it uses to actually expose an API, which is called the XDS API, to control planes such as Istio that can leverage this data and provide value-added services. So then let's dig deeper into the Mixer architecture. Essentially, Mixer is a rules engine, and it's comprised at a very, very high level, at the risk of simplifying it too much, by three different components, right? So you have a set of rules that defines exactly what actions need to be taken place, what actions Mixer needs to take place in order to facilitate integration with adapters that are supported. What an instance is to say, hey, what is this information that I need to send when a rule is matched? And then it's also comprised of these adapters. So I also wanted to showcase the fact that when you deploy Mixer and Istio today, you get a lot of inbuilt adapters that are built into the whole Istio framework, which provide lots of value-added services. So it allows you to perform some kind of RBAC, allows you to integrate a lot of telemetry into backends such as Prometheus. But I also want to highlight that now we have built a security adapter for Mixer, and we are the first vendor to build a security adapter for Mixer. I'm very happy to make that announcement today. So what we have done is we're going to bring we're going to leverage these capabilities provided by Istio in general. So Envoy actually surfaces 2 API calls. One is a check API call, and one is a report API call. And I think you can see how we actually progress with this. The check API call is used to enforce policy across your service mesh. And then the report API call is used to surface a lot of fine-grained telemetry and information about traffic patterns that are traversing your network. So having laid the groundwork for this mixer architecture, let's get into how exactly Palo Alto leverages this kind of a framework to provide this kind of deep security for containerized workloads. So before we get into that, I also wanted to talk about a certain pitfall blind spot, right? So what you see here is a subset of the Istio attribute vocabulary. So what that is these are the information that is surfaced by the Envoy proxies that can be leveraged for different use cases, right? But what I wanted to highlight here is the fact that, we're all coming from an enterprise world where we think IP addresses are very, very important. We have applications, static applications that don't change much, so we can leverage and hook off of the IP address. However, in a microservices world, things are changing very, very rapidly. You have a large number of services. So I just wanted to point out the fact that IPs don't mean much in this kind of a world. It means a lot from a networking perspective, but not from a security perspective. So we're going to show you how, this is what we talk about, up-leveling the framework provided by Istio to provide fine-grained security, where now we focus on transforming, for example, Palo Alto network security policies and map it into namespaces, services, application IDs, etc. So the first integration that we have built out using Istio is to leverage the report API surfaced by Envoy and Istio to show fine-grained telemetry about all accesses that are going on in your service mesh. So we now map this back to the attribute vocabulary, so we can tell you which source namespace that a request came from, what was the source service, what was the HTTP verbs, what was the action, what were the parameters for that connection, such as was encryption enabled, was there mutual TLS, etc. So this is very, very significant information, and I'm actually going to give you a story that I actually even real experience yesterday about the benefits of this capability, right? And if you don't have visibility into the traffic patterns of your environment, I think it's a recipe for disaster. So what we have done is we have actually hooked our security adapter, which is now called the Next Generation Firewall Policy Engine, to source information from Envoy and Mixer and actually integrate all that data, all the application logs and metrics into the Palo Alto Networks Cortex data lake. We have built out this adapter as a highly plug-in system. So consequently, we have also, the first initial integration that we have also done is with Google Stack Driver. So all of this information is now aggregated into a single unified console. And now you're able to reason about all your application patterns, what's going on. And now, as you can see, we can use this information to troubleshoot and also make sure that your applications are behaving as they should be. So the data source for all of this information is Envoy. We harvest all of the data and aggregate it into the Palo Alto Networks Cortex data lake. So here is a slide that gives you a sense of exactly, we have a lot of data going, but gives you an idea as to exactly what that data looks like. So this is a subset. As you can imagine, we can surface all the attributes that Envoy exposes, but to give you an idea, so you have a timestamp, you have a severity level of that, the logging, what was the source service that initiated that particular connection, you have the destination service, you have source IP, so you have a wealth of information that you can use to reason about exactly what's going on in your network. And this is highly configurable, so you can actually expose as much data or as little to suit your specific use case and purpose, right? And for convenience sake, what we've also done is we have provided all of this information in as a JSON blob that you can actually query and perform post analytics and other use cases to facilitate whatever you need to achieve. So once again, what are these benefits, right? So this kind of a posture gives you a record of all your containers action regardless of container lifetime. So that's very, very important because as you can imagine, in the traditional world where let's say that there was an exploit or a vulnerability, you could actually go in and perform forensics because that entity is actually available there on your network. It's not gone anywhere. But containers are highly ephemeral. So if an exploit has happened, I mean, that asset is gone. It's no longer there. But you need to have a record of exactly what was going on and the circumstances around that particular exploit or a vulnerability to be able to reason about what exactly happened. So you have now a record of exactly what happened and what is the use case there. So you can now conduct forensics armed with full data and to actually figure out what happens, and now you can actually improve your security posture. So now you can also, you also have the ability to map your container activities to malicious campaigns. You can index and integrate this, something that we have. I'm going to get dinged for this by Palo Alto, but as a roadmap item, we're actually going to integrate this with our threat intel cloud, and we can actually map these activities to potential malicious campaigns. So that's an incredible benefit, and you can also may use that information to enforce the right policies on your deployments. And last but not least, it's highly useful to perform security lifecycle review and assessments to say, hey, what's my posture? What are the applications going? What are the circumstances? Are they secured? What are the conditions around these applications? And can I actually sanction these, right? So those are a lot of the benefits, and that's the first use case, which is visibility into all aspects of your container deployments. The second use case and the integration that we performed is policy enforcement for service meshes on Kubernetes using Istio. So I'm going to walk you through a sequence of slides to show how Palo Alto has natively integrated with Istio's capabilities and the security framework to give you this fine-grained security posture. So Palo Alto has a product called Panorama, which is our management platform. So the Panorama as a plugin that can interact with Kubernetes clusters to extract applications, labels, microservices, et cetera. So this is the discovery piece where we discover all the services that are running on your Kubernetes environment, and we display that on our Panorama interface. Once that is done, we can actually deploy our security adapter onto your Kubernetes/Istio deployments to actually retrieve. The first thing that this security adapter does is it retrieves these policies that a user now has actually defined on Panorama. So the workflow there is that a user has a single unified security posture where they discover on the Panorama platform all the services that are running, and they can actually script security policies on our management platform to define what are the sanctioned services and interactions between their containers. What the Palo Alto Network Security Adapter now does is it retrieves these policies from Panorama and actually transforms them. So I will spend a few minutes in a later slide, but we actually transform. This is what I said. So now you have a unified posture where you can define security policies, and we actually transform them to Istio policies and make it actionable across your service mesh. So for example, what does this policy look like, right? So you can say, hey, I need my front end, my web application, which is running in my front end namespace. It can access the application, the application tier running in the app tier namespace on a specific port and a specific application ID. Similarly, this gives you can construct security policies that allow access between different namespaces and different services, right? So what we now do is then, what happens is anytime that, so before I get into the how, so this is like a typical microservices deployment. You have 4 microservices here. You have a web microservice, an application microservice, DB, and a pub sub. In this particular instance, the web microservice wants to talk to the application microservice. So the Envoy proxy, when that happens, actually performs a check call to the Palo Alto Network Security Adapter to say, hey, I have the web service in the front-end namespace that wants to access the app service running in the app tier namespace on this protocol with this particular application ID. So the security adapter now has retrieved all these policies and performed this transformation. And now it can say, yep, I have an entry, it matches. I can actually allow this, this particular connection to go through. So as you can see, the web service is now allowed to talk to the application service. Consequently, you know where the next slide is going. Let's say that your web service gets exploited, and there is a vulnerability, and somebody has been able to attack that particular application or container. So suddenly, you have your web service trying to access your DB tier, which is arguably unsanctioned because only the application service can access your DB tier. This is where your critical data resides. So this is unsanctioned. So similarly, however, Envoy will actually make the call to the Palo Alto Networks adapter to say, hey, I have this kind of an pattern access happening. Is this sanctioned? Clearly, it's not, because we don't have any rule which says that the web service in the front-end namespace can actually access the DB tier. So consequently, this access is denied. Also want to point out that all of this, even the policy enforcement piece, they're all logged into both Stackdriver and the Cortex data lake for you to reason about. So all of these are available for post-processing. So this slide here gives you an idea as to exactly how that logging looks like. So you can see that you have at the top, you can see that the mixer sent a check request to the Palo Alto Network Security Adapter, and we actually performed a lookup. And you can see that there were certain microservices in different namespaces access different destination services, and it goes through, it performs a lookup, and it'll actually also show you whether that request was allowed or denied. Right? So just to recap this, what are the benefits, right? You have consistent policy definition. As you can see, it's a unified single entity that security teams need to define their policies and then seamlessly apply these kinds of Palo Alto Network security policies, for example, and actually transform them to make them actionable across your container workloads in different environments for either Kubernetes, on-premise, or even your VM workloads. So as I mentioned, it also translates Palo Alto Network security policies to Kubernetes and Istio policies. And then, as I already mentioned, this consistent logging and feedback loop. I just want to spend maybe a minute talking about how exactly we transform these policies, as I'm going to show you in the demo so that you have the right context there. Palo Alto Networks is trying to be as cloud native and as container native as possible. And one of the artifacts that we're able to leverage is a concept called dynamic address groups, which is a very versatile, scalable solution. So what we do is for all your namespaces, we allow our users to define dynamic address groups, add DAG tags, as I call it. The tags represent all the different services that have been discovered from your Kubernetes environments. We add the source services. Let's say that we know that the web tier needs to talk to the application tier, so we will add all the services which form the source, which are initiating connections to the source dynamic address group. Similarly, we add all the destination services to the destination dynamic address group. We add all of these DAG tags, and this is how we can translate the Palo Alto Network security policy into Istio policies, and I'll show you exactly how that comes into play. So before we get into the demo, another salient aspect of this solution is the fact that we can now use a unified security posture that is Panorama and actually apply security policies, provide the visibility across heterogeneous environments. So for example, you can have an OpenShift Kubernetes cluster running on your on-prem, and OpenShift uses Istio for their policy enforcement and traffic management capabilities. We can obviously run on GKE or running on your GCP cloud, the managed Kubernetes provided by Google. And we can, and last but not least, we can also seamlessly run this kind of a posture using GKE running on your on-premise environments. So all of these entities, as you can see, will fundamentally consist of obviously Kubernetes, and we will use the Panorama plugin will actually harvest the Kubernetes labels, discover services, provide that single pane for discovery of all your services across all of these different environments on a single unified console, for example. We will then, the users, the operators will then define security policies, which can be highly automated. Everything that you do with the Palo Alto Networks devices are all API driven. And you can actually deploy all your policies onto Panorama and have them push to the next generation firewall policy engine. That's the name of our security adapter that's available on the Google Marketplace. I'm going to talk about that across all your different environments. And as you can see, you can you can now have all that data visible in your Cortex data lake. And I also mentioned I'm also going to show you how we actually aggregate all of the data into Stackdriver as well. So you can use a unified platform to now have a secure posture across different heterogeneous environments. And that's an incredible value that we see. And why is this important is the fact that I've spoken to many operators, many enterprises. I mean, we are on this container journey, but it's not going to happen overnight. What we typically see is you have your systems of engagement that are potentially going to be running on your Kubernetes workloads and the cloud, for example, but they are going to be accessing critical data that is resident in your databases, potentially in your on-prem environments. So it's very critical that you be able to have a unified posture to secure all these different environments. Because this is where Palo Alto came from as well, by the way. You can't have too many tools. I mean, you have there's a huge learning curve. I mean, that's also not a recipe for success. So having a unified security posture that you can actually apply across all these different environments is very important. So I want to showcase the fact that the Palo Alto Network Security Solution it's brand spanking new. There were a number of announcements that went out yesterday. It's available on the Google Marketplace, and now you can actually deploy this solution directly onto your GKE clusters running on GCP or onto GKE on-prem. I'm going to demo both of these. So as you can see here from your Google console, you can see two clusters. The fact that one is indicated as external on the top means that that's an on-prem cluster. So you can actually, from the Google Marketplace, you can deploy this solution across both your on-prem and your cloud running on GCP, GKE on GCP. And then, Ivan, do you have something to say about this?
Yeah, I just want to bring two salient points. So number one, at any point of time, you don't have to deal with the IP addresses. All that magic happens underneath. So you really only deal with the labels, Kubernetes labels, which you're familiar with, right? The secondly, as I showed you before, you don't have to worry about where these containers are deployed. As far as they're labeled correctly, like a web service or otherwise, we can set up policies for those. So your developers, as far as they label them or they have a prescribed way of how to label their containers, if they're developing web service or developing the persistent storage or something like that, as a microservice, that's all what they have to do. Security teams will just apply policies automatically on top of it. So you don't have to have any calls. You don't have to open a ServiceNow request. You don't have to do anything. Just deploy it, label it, and security follows.
Yeah. No, that's a great point, because another trend that Ivan is pointing out is the fact that developers need that agility. I mean, we've always hearing the fact that security teams are impeding that agility. But what if we can now have but security is a table stake. What if we can now show you how that it can be a win-win situation if actually security can have a very lightweight posture that really doesn't impede the agility that is required from your developers and the development team.
And it doesn't take away control from the security teams. I mean, that wouldn't work for us anyway. But they can work together. I think that's very important.
Yep. All right, so we've spoken a lot so far. Let's see, hopefully we can surface how all of this works in action. And there's a cop-out here. I wasn't going to challenge the demo gods, but I think Google has done a phenomenal job with their Wi-Fi infrastructure. But having said that, I'm still going to run this video. And if you could stick with me, we will, oops. Oh. I'll walk you through this video and show you how exactly we pull all of these concepts that we've talked about together. I'm going to stand here because I'm going to drive the video from here. So what we're starting off here is the Google console, and I want to show the fact that we have multiple clusters that we have deployed here, and now we're actually going to showcase all the artifacts that have been deployed on these clusters. These are existing clusters, and a highlight of this solution is the fact that as you can see, now let's say a common use case is our developers have gone ahead and said, hey, I need to use Kubernetes. I need to run all my applications. This is the posture that we need. And then the security team comes in and says, hey, what's going on, right? I need to know what's going on. So these are existing clusters, and we're going to showcase how this lightweight posture that security can actually be layered on without inhibiting the developer agility. So what you see over here is the fact that we have a very common, a popular microservice application, rather, that's been defined. It's got n number of microservices. For example, the carts is a microservice. Each one is a deployment. It's also a service. So you can see that there are 10 or 15 microservices that have been deployed onto this cluster. So what we're going to now show you is how we onboard these clusters into Panorama. Panorama is the Palo Alto Networks management platform, and we use that to onboard these clusters. And what happens when these clusters are onboarded is that they actually query the Kubernetes API and perform a discovery. So as you can see here, we have discovered that there are, at a high level, there are 4 services, for example. So you see the front-end service, you see a shipping service, and orders, and a payment. So this goes back to the fact that in this single pane, you can discover all the services that are running across n number of clusters, existing clusters across different deployments that you have on Kubernetes. So we have a second cluster, and we're also going to show you how we're going to, at this point, we don't have any, apart from the Istio ingress controller, there are no services that have been discovered on that cluster. So we're going to actually deploy an application onto the second cluster and show you how that these applications are discovered and exposed on the Panorama interface. So as you can see here, this is a very popular application. I like to call it the Hello World application for Kubernetes, but it's a very representative application. It's the book info application, and it essentially has 4 microservices. One is the product page, one is the details page, ratings, and reviews. What I didn't know, and maybe I should just preface this whole demo with this, is the fact that when I was trying to refresh and apply policy on this cluster, I couldn't quite explain to Ivan. He asked me the question, hey, what's going on? Why aren't you able to see all the data on certain refreshes? And I was like, that's how the application behaves. And I really couldn't give him a good answer. But turns out with all that visibility, I was able to answer the fact that there is a load balancer, and it actually load balances between different versions of these microservices. And that's also another benefit of Kubernetes, right? You can have different versions, and you can actually split traffic between all these different versions. And the fact that I wasn't applying the right security policy. So it's essentially the fact that we were playing role reversal, where he's the security team, and I was like, hey, my application doesn't work. I don't know why it doesn't work, but you got to provide the right security policy.
I think you gave me an actually great, plausible answer, which I bought in. So, yeah.
I said, I have no idea.
You said something which actually made sense.
Did it?
Yeah.
Okay,
Yeah.
I'll take it. But the point here is that I was actually able to go and look into the logs and see exactly what was happening, and I noticed that I didn't have the right security policy. But going through with this demo, you see all these different services, and now let's switch context to Panorama, where I can actually show you that we have discovered a lot of all these microservices that are running on this particular cluster. So I see that I don't have all my services, so you can actually force a synchronization between Panorama and the Kubernetes cluster. And once I do that, I see that I have all my services discovered. So what this essentially allows security teams to do is they're coming back. Their application teams, the developers are using Kubernetes, GKE, et cetera. They've already deployed their applications. But I now, as a security SecOps person, need to know exactly what's going on so that I can enforce the right security policy. So the next thing that we're going to do here is to show you how we create those policies. So now I know what services are running, and I can say, OK, I'm going to script the security policies. So I'm going to pause here. So I just want to spend another few seconds on exactly what's going on here. I talked about the fact that we're going to define security policies, because Palo Alto has a lot of enterprise customers that have a lot of their development teams moving to microservices, Kubernetes, et cetera, right? So they are used to defining security policy in a certain way. But we've also talked about the fact that that's not going to work. We need to be able to reason about namespaces, sources, and apply security policy with that kind of a cadence. So what we have done is we are allowing our security operators to define, as I mentioned, we're going to define source groups where we will add all the services that are going to initiate the connections, and we're going to add destination address groups, and we're going to define the services that are the recipients for those connections. And then we're also going to add certain other attributes which will allow us to now enforce this policy. So I'm going to show you how we are creating the source address group, which is essentially constituted with all the services that are going to initiate these connections. And I'm going to add these dynamic address group tags, as I call it. And what I've actually done is I've added all the different services that I've discovered in my cluster into my, my DAG tags. And now I can add them as these are the source services that are actually going to initiate connections to destination services. And similarly, we do that for the destination groups. These are the tags. And this now, we actually use these tags to define a security policy. So as you can imagine, I have a couple of different services, and I'm going to define a security policy for the book info application. And I also want to showcase the fact that this is highly scalable. All you need to do is once you define a security policy, you just add tags to all the different service pairs, if you will, that you need to define. So we're going to actually leverage the source dynamic address group, which is called book info source namespace. And in the destination side, we're going to add all the destination services. So now you see we're defining the security policy. And on the right, you can see here a service. We can actually define service objects. What the service object can represent is what is the protocol that is going to be leveraged. For example, is it going to be HTTP? Is it going to be HTTP2, gRPC, et cetera? So you can define all aspects of your service communications and represent it as a security policy. And I'm actually going to show you that. So you can see that we are actually referencing the source namespace, which is constituted with all your source services. Similarly, for the destination, we have also defined what is the protocol, the service, it's service HTTP, and the action is to allow this kind of a traffic. So once we have done this, we can actually commit this to Panorama, and it's ready for consumption. Whenever our security adapter is deployed onto a Kubernetes Istio cluster, they actually punch in and check in with Panorama to retrieve these policies. So let's take a look at this. Right now, the book info application is up and running, and it's accessible. So let's now deploy the Palo Alto Network Security Adapter from the Google Marketplace. So as you can see, I just wanted to walk you through and show how you can configure and deploy. You see all your existing clusters. You can pick and choose which cluster you want to deploy this application into. I picked the Panorama IP. I pass it in as the endpoint for where I want to retrieve all my security policies. And then I deploy the application. The Google Marketplace deploys the application on that cluster, and it's up and running at this point. So what happens now is I'm actually going to switch context and actually show you what are the logs that when this adapter is essentially a container that is running on your Kubernetes environment. So it's actually interacted and connected with the Panorama device, and it's retrieved the security policies, as you can see, and it's translated those security policies from the Palo Alto Network's language into policies that can be applied across your cluster. I'm going to quickly pause here to show that this is to represent how you can actually now set up your rules, as I told you. So Istio needs to know, OK, hey, I have an adapter here. It's just sitting there. What's it going to do? But what you can see here is now actually say, hey, I'm going to define an instance that characterizes the data that I want to send to this adapter. So this is what we will leverage from a logging perspective. This is a very subset of the data. And similarly, we will also define the rules according to which Istio will send the telemetry to our adapter. And similar kind of a posture is applied for your authorization checks as well. So this is what the YAML file looks like to actually set up all the plumbing for Mixer to send a lot of the policy checks and the log telemetry to the Palo Alto Networks adapter. And we're now going to apply this YAML file. So once we do this, we see that, which is what I told you, which is I went through this. The rating service is not available. So I don't have the right security posture. I have a lot of policies defined, but something's missing. So the next thing that I did was I actually went into the stack driver interface to say, hey, let's figure out what's going on. I have fine-grained data and everything that happens. So I know there are authorization checks that happen. And I know, for example, there was an access was allowed, but there were also possibly some accesses that were denied. For example, I know that reviews version 2, the reviews version 2 service was talking to the rating service. I had no clue, but this is the way you can see which applications, which microservices need access and talking. Similarly, I immediately jumped to my Panorama. I updated my policy to say, hey, okay, I need to add a new service that needs to initiate connections. So the reviews version 2 service needs to talk to the rating service. I create a new tag for that. I'm just giving you the whole experience, right? So forgive the pauses here. But now seamlessly it gets updated to the address book, but you don't have to update your security policy. That's key here. You just keep adding services dynamically to this address group, and it can seamlessly get applied. So we're only manipulating the address group here. We're adding the reviews version 2 service. We commit it. And then the new policies get periodically pulled by the adapter. As you can see, we have the reviews version 2 that can now, reviews version 2 can talk to the rating service. So now we have this security policy. Once we go here, now your rating service is available and accessible, and you can see it. So this just walks you through the fact that now you can actually go back and corroborate. Hey, OK, I actually had this kind of an access happening. I have all the logs available to me. But then what I actually found here, what I'm actually saying is, hey, we're not done as yet. There's another reviews version 3 that wanted to talk. So I'm going to speed this up a little bit. But we can, similarly, you can see the cadence, right? You can actually go and add the new service, and everything is up and running. But I just want to reiterate the point that now you have full visibility into all the applications and the workloads, and then you know exactly what were the authorization checks, who was talking, whether access was approved or denied, right? And all of this data is available on a stack driver and our Cortex data lake. But what I want to actually show you here is the deployment. Sorry about this. I'm going to showcase the deployment of the Palo Alto Network Security Adapter onto the GKE on-prem. So directly from your marketplace, you can actually deploy your adapter onto your external cluster, which is actually sitting on your on-premise environments. You go to the marketplace page, you pick the adapter, you configure it, and you specify the different deployment models, and it actually seamlessly gets deployed onto your cluster. So once again, I painted that picture of heterogeneous environments, and this is incredibly valuable because now you have a unified security posture with all your data aggregated into either Stackdriver, for example, or the Palo Alto Networks data lake, and then you have a unified framework to actually deploy policy. So you have discovery and policy enforcement from a single point. So that kind of wraps up, actually, in good time. We have a few seconds left, but Ivan, would you like to
So just kind of interesting point here is that this is all done in a live cluster without any interruptions, right? So just deploy the adapter, and you can just start using it as is. So you might already have your infrastructure deployed.
Yeah.
You want to play around with this, or you want to start using it. You can just deploy it down, and game on, right? That's as easy as that.
Yeah, it's very easy to adopt, and it was, and we have all the YAML files on our GitHub pages, but it's also been incredibly more easy to deploy now that it's available on the Google Marketplace. You just point, click, and it'll be available and ready to deploy. And please, we'll be hanging around for a few minutes. Sorry, we went right up to our allocated time, but we are happy to answer any questions. And thank you so much.
Yep.